This is the mini lesson for 2.1. Bob and his little brother Jake want to build bird feeders to sell at a local farmer's market. They have enough money to buy materials to build 10 bird feeders. If Bob builds 5 bird feeders, how many will Jake need to build? Okay, so if they're going to build 10 total, then Jake has to build 5. So let's just complete the table. If he builds 10, he's going to build 0. 9 plus 1 makes the 10. 8 and 2, and I see a pattern, so I'm going to just run with this pattern. So it's important to see that in every single row, the sum of the two numbers is 10. Okay, so if we're going to complete the table by graphing these quantities, I'm graphing, this is built by Jake. So when Jake built 0 from the table, Bob built 10. And when Jake built 1, Bob built 9. When Jake built 2, Bob built 8. And I can keep putting these points on. I gotta make sure I keep them even. Okay, so I plotted all my points. Now it says to draw a line connecting the points. Best to use a straight edge, but I'm just going to quickly put these points in. Describe the line you drew. Do all the points make sense in terms of the problem situation? This is a good question for us to think about because when we connect the points, we found out yesterday that that is continuous data, which means any point along this line would make sense. So since this is about building bird feeders, did it make sense for me to connect the points? And I am going to say, first of all, to describe the line, I'm going to say that my line is straight. And do all the points make sense? I'm going to say, yes, they do. And here's my reason. They're building bird feeders. So Jake could build, just say half a bird feeder. And then Bob would build 9.5. So Bob could finish the one that I started, and then he could build 9 more to still have 10. Now, if this question was about the number of bird feeders sold instead of built, then it would be discrete data, and I would not connect the points because it wouldn't make sense to sell half of a bird feeder. So describe how the number of bird feeders built by Bob affect the number of bird feeders built by Jake. Well, the sum, which means addition, of Bob and Jake must equal 10. So this question asks, what's the ratio? When I see ratio, taking fractional form, what's the ratio of bird feeders Bob builds to the number Jake builds? That means Bob has to go on the numerator, Jake on the denominator. So I'm actually going to go back to the table here, and I'm going to pull up a few different examples. Bob built 10, Jake built 0. Try another one. If Bob built 7, Jake built 3. If Bob built 2, Jake built 8. Are these 3 ratios equivalent? And I would say no, they're not. So because these are not equivalent ratios, there is not one ratio for this problem. Sometimes you guys are going to see that there will be ratios that will work for every single every single point we take off the graph for every single thing from our table.